Okay, so my name is Stefan. Today we're going to talk a bit about boundary value analysis. Why? Because it seems easy, but it's really not that simple. Okay, the basic, if you do a quick search on the internet, boundary value analysis, you have the same lame example. Let's say you have a string of characters, 1 to 24, and the way you do boundary value analysis is you test for 1, 24, then you go outside the boundaries.
Could you
and you test.
Speak slowly?
No. And then you test 0 and 25, and then you go inside and you test 2 and 24. Yes, boundary value analysis, that's it, that's the secret. Well, not really. Why is that? Well, a prerequisite of applying boundary value analysis is that beforehand you have separated the values into equivalent partitions. That's nice. Well, what does equivalent mean? Well, okay, so we have numbers 1 to 24, positive integer numbers. How are they equivalent? How is 5 and 7 equivalent? Can somebody help me?
5 and 7?
Yes.
Equivalent in what sense?
They're one character.
How are they equivalent? They're one character.
The-
Yes, but you spell 5 with an F. You
The
can't
pri-
spell 7 with an
The
F.
prime numbers.
Yeah, but 5 is smaller than 7. How are they equivalent? What does equivalent mean for that partition? Well, as I found out, they're equivalent because they have the same chance of finding the same bug. That's how they are equivalent. So that means that the numbers that we didn't test for have the same chance of catching a bug, which is testing that the number is a positive integer single digit. But what about the other bugs? Maybe the characters, they are used for comparing two numbers. But in the backside, in the programming side, they are represented as strings. Well, 9 string, it's not the same as 9 the number. So when you do comparison, you may find some interesting bugs, like 9 is the biggest of the numbers from 1 to 24. That's an interesting thing. Okay, second, why the hell do we use boundary value analysis? Well, can't we just test all the values? Well, we could, but in software testing, we have to test multiple features. So we have to measure about how much are we testing versus our coverage. So we use boundary value analysis to say, okay, we're going to test here a bit, and we're also going to cover more features. Comparing two, we're going to test just these small fields, and then we don't have any more time. So we use boundary value analysis to gain more time. I was thinking we're using it to cover for bugs or reduce the chance of bugs appearing there. But we're actually just covering the chance of the certain bug for the equivalent partition and the boundary value cases. We don't cover for the other bugs. There's still a lot to cover. Well, okay, 3 ways to improve your boundary value analysis testing.
That one first.
From the oven. Well, the first one is randomization. Why? Because if you always input a random number from 1 to 24, there's a chance that you will cover the bugs you didn't search for. That's the smallest one you can do, and starting right now. Okay, second one, it's called steeplechase. What does steeplechase mean? Well, you saw the obstacle course for the horses. They run and jump to obstacles of different types. Well, that's the life cycle of a variable inside the system. Because you have a check in the input field, but maybe alongside in the program, there's a check that it's smaller. So you have an input character of 50 length, but somewhere inside the programmer says, oh, 50, nobody's going to input 50, and it put 12. That means you not only apply boundary value analysis at the start, just in the input field, but you you use the values inputted all along the life cycle of that specific variable till the end. And that's why it's called steeplechase. You run the variable to multiple obstacle course to see that it passes through all. Okay, and the last one, it's called creep and leap. Why is it called creep and leap? Well, creep means what's the I promise I'm gonna finish really fast. Creep is what's the smallest violation that I can do so the program won't allow my values. The smallest violation, not the biggest one, the smallest one. And leap, what's the biggest number, the biggest value I can use without breaking the system. It's a bit compared to the first part you find on the internet, but it gets you in a different mindset. You start thinking about why is this variable going to be used? What's the largest number I can use? You start thinking a bit differently. Basically, these are all free. I am currently working on an animated version of this. If you have any suggestions, examples of weird boundary value cases that you encountered throughout your testing, or ideas, I am happy to receive them. You can tell them on my meetup. And I promise you, after I finish with the drawing, I will send it on the meetup and show it to all of you. I'm done.
I have a fourth one that you might want to look up. It's called symbolic execution. There's some guys. Yeah. There's some guys. They started at APFL in Switzerland, and now they're working for Google. And they have this smart way of symbolically executing a program and finding boundary values. You might find it useful.
Nice. Thank you. Thank you for your time. I hope it was working.